Hello friends, welcome back. Today again we'll be doing a problem related to electrical machines, and the problem is a 400 volt 50 hertz 6 pole delta connected 3-phase induction motor consumes 45 kilowatt and the line current is given as 75 amps, and it runs at a slip of 3%. If the stator iron losses are 1200 watt and the windage and the frictional losses are 900 watt, uh, and if the resistance between the two stator terminals is 0.12, then the copper losses are. So we need to find the copper losses and the above uh, in above conditions. Okay, so let us see what is first given to us. So slip is given to us, so we can write as slip is given to us as 0.03. Okay, again, if we notice here that it is delta connected. Okay, so this thing we have to keep in mind, and the line current is given to us. Okay, so let us see what exactly is trying to say. So say this is the stator windings which are delta connected. So we are given this line current, okay, I, and this is given to us as 75 amps. Now the individual currents, because all the three phases will be balanced, it will be root 3 times. Okay, so phase current, I can say each winding current, I can say winding current equals 75 by root 3 amps. Okay, so this is also known to us. Now what is again also known to us is iron losses. Okay, iron losses. Okay, so these are 1200 watts. Okay, this is also given to us. So if in input power, okay, I subtract iron losses and also the in stator copper losses, stator cu losses, then what I get is air gap power. Okay, so this is my air gap power. Okay, so this will be my aim, because once I get air gap power, and S times air gap power means slip times air gap power will be my copper losses of rotor. Okay, so these will be copper losses of my rotor. So I need to calculate this stator copper losses. Okay, and iron copper losses are already given to us. If I multiply it with input power, now input power is given to us is 45 kilowatt. Okay, if I subtract these two losses, I get air gap power, and from air gap power, if I multiply it with slip, I get my copper losses of the rotor. Okay, so let's see how we proceed. Now see here, he is saying that the resistance between the two stator terminals is 0.12. So let us, because it is delta connected, so it is somewhat like this. If I only show you this R and R, and he's saying any two terminals. Okay, so these two terminals, now you can see here that these two resistances will be in series. For that combination, if I draw it again, it will be like this, R and small r. Okay, and here we are measuring, so it will be R in parallel with 2R, which will be equal to 2R square by 3R, so it will be 2 by 3 of R. So this is given to us. Okay, so 2 by 3 of R is given to us, which is equal to 0.12. So now from here R is equal to 0.12 into 3 by 2. Okay, so this is 0.18 ohms. Okay, so this is our one winding resistance. Okay, so resistance of one winding. So now if I get that, I already know my current of each phase or each winding. I is 75 by root 3 as we discussed earlier. Okay, so now my copper losses of stator will be 3 into I square R 75 by root 3 whole square into R 3.18. Okay, and if you do this calculation, what you get is 1.0125 kilowatt. Okay, if I divide it by 1000, okay, this whole thing, and I can convert it into kilowatt. So these are my copper losses of stator. stator. Okay, so once we have copper losses of the stator, now what we can do is we can find the air gap power. Okay, already the air gap power is given to us. Already the input power is given to us, which is 45 kilowatt. Okay, minus what is my, and I have to subtract this. I have to subtract what I have to subtract. I have to subtract copper losses of stator and one more thing, that is the iron losses. So when I do that, what I get is 45 minus 1.0125 minus, this is 1200 watts, which will be 1.2 kilowatt. So I write 1.2. Okay, so when I do that, I get 42.7875 kilowatt. Okay, so this is what I get. Now once we have the air gap power, now the task is simple. S times air gap power, power is going to give me my copper losses of rotor. Okay, so what I can do is I can simply multiply S with, okay, now I know my S. Okay, S is going to be 0.03 as already mentioned in the question. Okay, here you can see it is 3%, which will be 0.03. So copper losses of rotor will be 0.03 times the air gap power, which we calculated as 42.7287275. Okay, now if you do this calculation, what you get is 1.283 kilowatt. So our copper losses of the rotor are 1.283 kilowatt. Okay, so this is our answer. Okay, 1.283 kilowatt. You can see here that friction and windage losses are also given, but you do not need to subtract those. Okay, if you do that, you will get a wrong answer. Why? Because these losses will come after your air gap power. Okay, so from air gap power only you need to calculate the copper losses of the rotor. This thing you need to keep in your mind. Please don't add this to the losses. Okay, if you subtract this from the input power, then you will get the wrong answer. Okay, so this is thing you have to keep in your mind. Okay, rest this question is a very easy question. Okay, so thanks for watching.